Hello guys, in this video we are going to discuss the solution of the problem Recamans sequence. So let us look at the problem statement. The problem statement says that we are given an integer n, return the first n elements of the Recamans sequence. It is a function with domain and codomain as whole numbers. It is recursively defined as below. So that is the Recamans function is something like let an denote the n plus 1th term, 0 being the first term. Then the rule says a0 equals to 0, that's the base case, and then an is equals to an minus 1 plus minus n if this is greater than 0 and is not included in the previous sequence, and an equals to n minus 1 plus 1 otherwise. Okay, so let us try to understand the problem with the help of an example. Here n is equals to 5. So if n is equals to 5, then the Recamans function, so what will be the first 5 values of the Recamans function? So well, we know a0 is equals to 0, so that will be the first one. a1 is equals to, so let us write the Recamans function, an is equals to a of n minus 1 minus 1 if a of n minus 1 minus 1 is greater than 0 and a of n minus 1 is not included in the list, is not included in the list. Okay, if these two conditions are satisfied, so this is my condition 1, right, and this is my condition 2. If these two conditions are satisfied, then we are going to evaluate an equals to this. Otherwise we are going to say an is equals to a of n minus 1 plus n. Okay, so now let's operate on this. So here a1 equals to, so let's try to see if we can fix it into this. So a1 is equals to a0 minus 1, so this is equals to a0 is 0, so this is 0 minus 1, which is equals to minus 1, which is less than 0. So in this function this will not fit. That is why a1 is equals to a0 plus 1. So this is equals to 0 plus 1 and this is equals to 1. Okay, now let us look at 2. So a2 is equals to a2 a1 minus 1. a1 minus 1 is what? 1 minus 1, and 1 minus 1 is equals to 0, right? And since 1 minus I'm so sorry, this is equals, this is 2, right? This is 2, so here it will be equals to minus 1. Again minus 1 is less than 0, so we are going to evaluate it as, so it will be evaluated as this a1 plus 2, which is equals to 1 plus 2, which is equals to 3. So let's print our list also. So this is the first element of the list, this is the second element of the list, this is the third element of the list. Moving forward, a3, so a3 is equals to a2 minus 2. Let's do that. a2 is what? a2 is a2 minus 3, I'm so sorry, a2 is 3, 3 minus 3 is equals to 0. So this is not equals to, this is not greater than 0, right? We want this to be greater than 0. So since it is not greater than 0, so that is why we are going to evaluate it as a2 plus 3. So this will be equals to a2 is 3, 3 plus 3, which is equals to 6. So this will be 6. And let's move forward. So this is the fifth and final element of the list. So a4 is equals to a3 minus 4. a3 is 6, 6 minus 4 is equals to 2, and 2 is greater than 0 and 2 is not there in the list. That is why we are going to evaluate it as this, and this will be our last element of uh, the series. So that is how we are going to evaluate it. Now let us see how we will be able to code it. So what we are going to do is, so let's say this is my Recaman function which I am trying to define, and n is given to me. So what we are going to do is we are going to take a DP table, and this will be of dictionary type, and we are also going to take a key table which will be also of dictionary type, and third is our answer list. We will have an answer list, and the first element of DP 0 is equals to 0. Similarly, key 0 exists, so that is what we are going to do. Key 0 is equals to true. We are going to say that 0 exists. Sixth is we are going to append the first element of the series, which is 0, into the answer list, and now we are going to iterate on the rest of the series element. So for I in range 1 to n, okay, so the first thing which we are going to evaluate is if dp of I minus 1 plus, sorry, minus I is greater than 0. If this is greater than 0 and it is not included in the list already, so if dp of I minus 1 minus I not in keys, okay, so the keys is to hold. So okay, I'll go through an example in order to explain this. So this will be, in that case, this will be equals to dp of I is equals to dp of I minus 1 minus I. Otherwise this will be equals to dp of I is equals to dp of I minus 1 plus I, and then we are going to say that this dp of I exists now in the list, so we are going to mark it as true, and we are going to append our answer also. So let's append the latest element of the series in the answer, so dp of I, and once this loop is complete, then we are going to return answer. Okay, so let us go through an example in order to see what we are actually doing here. So let's take the same example. N is equals to 5. So we needed two tables, which is dp, okay, and there is another table which we are maintaining, which is equals to key. And initially we said that 0 is equals to 0, right? dp of 0 is 0, and we said that since 0 exists in the list, so we are going to mark it as true. And then we had our answer list. So answer list initially contains only one element, which is 0. Now we are at position where I is equals to 1. So when I is equals to 1, we evaluated dp of I minus 1 minus I. So this turns out to be 0 minus 1, which is equals to minus 1, and this is less than 0. So because of which dp of 1 will be equals to dp of 0 plus I. So what we are going to do is this becomes equals to 0 plus 1. This is equals to 1. So once we get 1, we are going to append 1 into our answer list. So let me just let's just get rid of this, and so this we are going to append 1 to it, and since 1 we have 1 exists in the list now, so we are going to mark 1 equals to true, and we are going to have 1. So dp of 1 is what? dp of 1 is 1 in the dp table. Now when I is equals to 2, again we evaluated dp of 2. So dp of 2 is equals to dp of 1 minus 2, and this turns out to be less than 0. So that is why we are saying that dp of this will be equals to 1 plus this, and dp of 1 is 1. 1 plus 2 equals to 3. So again we are going to make an entry in the answer. We are going to say that 3 exists in the list, so 3 equals to this, and 2 and the second element or the third element of the series is 3. Okay, moving forward, when I is equals to 3, so we said that dp of 3 is equals to dp of 2 minus 3, which is equals to 2 is what? 3 minus 3, which is less equals to 0, which is not greater than 0. So this will be evaluated as what? dp of 2 plus 3, right? So this will becomes 3 plus 3, which is equals to 6. So again 6 is there, so we are going to mark here 6. 6 exists in the list, so 6 is true, and the third is 6. Now let's move forward. So now we are at the last element, which is I equals to 4. dp of 4 is equals to dp of 3 minus 4. So dp of 3 is 6. 6 minus 4 is equals to 3, and 6 minus 4 equals to 2, and 2 is greater than 0, and it does not exist in the key, right? If you see the key, it does not exist in the key, so that is why we are going to have it as here 2 is equals to 2, and the fourth is 2, and this is what, and towards the end, this is what we are going to return. So that's about the explanation, folks. Now let us look at the code for it. So the code looks something like this. So we started with dp and key. So the first element is 0, and since the first element exists, so 0 equals to true, and in answer we appended the first element, then we iterated on the rest of the elements. If this condition is satisfied, then the dp will be evaluated as this, or the ith term will be evaluated like this, otherwise it will be evaluated like this. Once that is there, we are appending the ith element in the answer list, and we are marking that the dp of I now exists in the list. So this equals to key of dp of I equals to true. Okay, and towards the end we are returning answer. So let us submit our solution. Our solution got accepted. So that's from this video, folks. In case if you have any comments or question regarding this video, please feel free to use the comment section, and I will try to address them. Thank you.